In this lab, we will look at the recommender systems. We will apply recommender systems for data analysis. Recommender systems are widely used in many industrial companies, especially location-based service such as Yelp One. Yelp provides a very big data set for research papers. See the Kaggle page, https colon backslash backslash www.kaggle.com backslash yelp dash dataset backslash yelp dash dataset. To make the task feasible or on most of the laptops and PCs, we have extracted a manageable subset of the datasets, which contains the reviews on business in Las Vegas. The data format for users and businesses are exactly the same as in the description on the Kaggle page. The review file only preserves the review ID, business ID, user ID, stars, ratings, and date to keep the dataset small. Preprocessing for the preprocessing, split split the review data into training and test sets. Use the 20% latest reviews with the largest date attribute for testing and remaining 80% for training. So number 1, item-based collaborative filtering. In this task, we will build an item-based collaborative filtering algorithm on Yelp. Our first step is to pre-compute the similarity between each pair of businesses, that is, items, on the training data, such that we don't have to compute the similarities on the fly. Here we use the cosine similarity for simplicity. Okay, so some of the libraries that we import is we import pandas as PD, import numpy as NP, import GC, import GC is for garbage collector. From pandas.api.types, import categorical dtype. From collections, import default dictionary. From scipy.sparse, import CSR underscore matrix, import time. Let review underscore df equal pd dot read underscore json of the bracket, the name of the file, review.json, comma, lines equal true. Print review dot review df. So review df has 4 columns of data information. So the columns are review ID, business ID, user ID, stars, and the date. And there are 858,184 data rows and 5 columns. Let's sort this data frame by the date column. So review df dot sort underscore values bracket date comma in place equal true. Printing the review df. So we can see that the date is now so the data frame is sorted with the date column, and we can see the date, the year of the date starts from 2004. The date starts from 19 October 2004 and ends on 13 December 2019. Okay, so the data frame is sorted now, and we will delete the review ID column and the date column from the data frame because we no longer need them. So del for delete, review df, the name of the data frame, and then square bracket, the name of the column, review underscore ID. Then del for delete, the name of the data frame, review df, then square bracket, the name of the column, date. Printing review df, let's run this. So we see that now the data frame contains 3 columns: business ID, user ID, and stars. There are 3 columns and 858,184 data rows. Okay, now we split the data frame. We want the test column. The data frame is arranged in ascending order from least recent to the most recent date. So we want to select 80% of the data rows has trained data set, and the 20% that is the most recent data set data rows from this data frame has the test set. So train comma test equal np dot split bracket, the name of the data frame, review df, comma, square bracket, int, bracket, 0.8 times length of the data frame. So that will be 80% of the review data frame. And then close the brackets, print so train data set. So print the train dot shape and print the test dot shape. So train data set is having 686. Let's run this. Is having 686,547 data rows and 3 columns, and test dataset has 171,637 data rows with 3 columns. Let's print the train dataset, and let's print the test dataset. Now we no longer need the review data frame, so we delete review data frame and we apply the garbage collector, gc.collect open and close bracket. Okay, so gc.collect open and close bracket releases the memory that is not being used. And it gives 8. Okay, then let business ID equal categorical data type of sorted train.businessid.unique, comma, ordered equal true. Let's see step by step what this gave. So train.businessid gives the all the business IDs in the train data set, and dot unique train.businessid.unique open and close bracket gives the unique business IDs. So there is no repetition, and then we sort this. So sorted of train.businessid.unique open and close bracket sorts the business IDs, the unique business IDs. And then if we do categorical data type of bracket sorted train.businessid.unique open and close bracket, comma, ordered equal true, that gives the data type to be categorical. So you can see ordered equal true and categorical data type. And we do the same for user ID and let it be equal to use ID. So categorical data type of sorted of train.userid.unique open and close bracket, comma, ordered equal true. Then we do the mapping. So I'll just show you. Okay, for the mapping, that is creating a dictionary, we take the business ID and then we look at categories of it. So dot categories of square bracket I and then colon I for I in range bracket length of business ID dot categories. So what is the length of business ID? That's 7,584. And if we put range of length of business ID dot categories, that would be range from 0 to 7,584. And if we do business Kelly braces, business ID dot categories I colon I, where I is in the range of length of business ID dot categories, that will give so each of the categories will be marked with a integer number. So, and that equal to BUS map. Okay. Now, if we do default dictionary of lambda colon -1 comma BUS map, then this creates the default dictionary. Let's have a look. So now we have a dictionary being created. Default dictionary being created has a function. So that will be a function. And we do the same for useMap. So let useMap equal curly braces useID dot categories square bracket I colon I for I in range bracket length of useID dot categories. Let useMap equal default dictionary of lambda colon -1 comma useMap. Okay, now we create a matrix. So this is so now we create a matrix. So let me insert a cell above. Now train bracket stars. So this will be matrix of stars. Stars values from the train data set. And then the location of these data set will be, so the raw number will be train.user_id. So train.user_id hash type useID. So we know that useID that we created, that was of categorical data type. So hash type useID, that will be categories. So we can see the data type is category now. Then .cat.codes. So you want the codes. We don't want these long names, but we want the codes, the letters. And we have already created the default dictionary of useMap. So this has given us the codes. Now that will be the rows of the matrix. Now for the columns of the matrix, that will be train.businessID. So train.businessID gives the IDs of the business ID column. Has type BUSID. So BUSID, we put that as categories, sorted categories. So show you. Has type BUSID. So that is the categories. Then .cat.codes will be reading from the function, the default function that we created of the business map. Okay, So we can see the codes are printed. Now we are creating the matrix of the stars data set, where the location of the stars value will be where the row number is train.user_id.s type of useid.cat.codes, and the column numbers will be train.businessid.s type of businessid.cat.codes. And then the shape will be useid dot categories dot size, that will be for the rows, and for the columns it will be business id dot categories dot shape. So if we take this and put it over here, the number of rows will be 39,894, and the number of columns of this matrix will be 7,584. And CSR underscore matrix comes from the, we have imported this library from scipy.sparse. From scipy.sparse, import CSR underscore matrix. So printing RATM, let's run this, and that is 39,894 by 7,584 sparse matrix of type. Class is numpy.int64 with 686,547 stored elements in compressed sparse row format. So if we do, if I multiply these two sizes, the use ID size and business ID size, then that's 302,556,096. So that many entries. But the stars value in the train data set is 686,547 size. Then the rest of the values will be 0. So now so now we apply cosine similarity. From sklearn.matrix.pairwise, import cosine underscore similarity. Let st equal time open and close bracket, and this time function, this is from the library where we imported time. So st is for start, let it equal to time opening close bracket. Let similarity underscore sk, that is cosine similarity, equal cosine underscore similarity of this matrix RATM dot T, capital T, and this capital T is for transpose, comma, dense underscore output equal false. Then let ed equal time open and close bracket, printing ed, and this time is in seconds. So to convert it to minutes, we do ed divided by 60, because 60 seconds equal 1 minute. That will be still huge. So let's divide this by another 60 to get hours. $479,424. That much of time. Okay, now let's print similarity underscore sk index 7584 times 7 by 7584 sparse matrix of type class numpy.float 64 with 1,510,000 sorry 15,104,134 stored elements in compressed sparse raw format. And if I do 7584 times 7584, that's 57,517,056, but only 15,104,134 values are non-zero.